I want to go over some of the characteristics of water because water is just crucially important to life. In fact, when astrobiologists are looking for life on other planets, they don't look for life, they're looking for water because we think where we find water, we'll find life. Also, water, of course, has physically shaped the Yellowstone ecosystem very dramatically, and we'll be looking at some of those features later on. But looking at water then, one of the characteristics of water, which is an important characteristic of water, is that water molecules are cohesive. So we talked about how water molecules are polar, covalent bonded, so they're regions of positive and negative charge. And so as a result of that, then you end up with water molecules being attracted to one another, and that's why water forms droplets, as opposed to oils. If you put them on a surface, they just run flat. Oils are nonpolar. Yes, nonpolar, so they behave differently than water. So another characteristic is that water is adhesive, and so what that means, if something is adhesive, it will stick unlike substances together. So, if I had a paper towel and wadded it up and threw it up against the screen, it would just bounce off, but if I got it nice and wet and I threw it up against the screen, it might stick. And so what happens there is that the water molecules are sticking to the screen, they're sticking to one another through cohesion, and then they are also sticking to the paper towel molecules, and so that would adhere the paper towel to the screen. Another characteristic of water is that it exhibits what we call capillary action. So water tends to move up a tubule. Capillary is a reference to a small tube, and water will literally crawl its way up tubules. It sticks to the sides of the container and then pulls water molecules up. So again, if you had a container of water, and you may have noticed this with straws when you have a straw in some kind of beverage, the thinner the tube, the higher up the tube water will go. So again, we call this capillary action. It doesn't require any extraneous energy source. It's just a characteristic of water. And so that's really important to plants, for example, because plants have these tiny water-conducting tubules, and so that permits water to come in through the roots and eventually out through the leaves, and as that water flows through the plant, it will take atoms and molecules with it. Another characteristic is that water has a high surface tension. Again, this has to do with that cohesive nature of water. So water molecules kind of cling together, and so this is why small insects and so on can actually sit on the surface of water. If that was oil, that insect would have embedded itself in the oil and suffocated in the oil. Another characteristic, water has a high specific heat. So what that means is that water is slow to heat and slow to cool, and as a result it will have a high boiling point, which I'll get to in a second. But water molecules, again, being cohesive, you can add energy to water and it won't change the temperature within certain limitations. So the measure of temperature is actually the amount of movement of particles. So water molecules, because they're cohesive, can absorb some energy without really changing the amount of movement, and then as you get to a certain point, the movement increases and temperature will go up. But once they are moving, then they tend to keep moving, and so that maintains their heat for a longer period of time. So again, we especially see this along coastlines where oceans can moderate coastal temperatures. So the extremes between night and day temperatures are much less along coastlines than you would have in the interior. So again, there are no oceans, of course, in the Yellowstone ecosystem, and so we do see extreme temperature fluctuations. I've been up there when it literally snowed in the morning, and then it was 90 degrees the same day. So anyway, so we don't see this moderating effect in Yellowstone. Water has a high heat of vaporization or high boiling point. So again, this has to do with having a high specific heat. Additionally, and this is really, I think, an important characteristic, is that water is a solid. When it is a solid, when it is ice, it is actually less dense than the liquid form of water. That's unusual. Generally the solid form is the densest form, but here the solid form actually traps air. Ice has kind of a crystalline structure to it, and so it will float on water. And so what that does then is insulate the water underneath. So something like Lake Yellowstone can freeze solid across the top, but that insulates the underlying water, and so this allows the microorganisms and fish and other organisms that are aquatic to survive the winters, and otherwise, it would freeze solid. So again, this is somewhat unusual. And then another characteristic is that water is a good polar solvent. So what that means is that particles readily dissolve in water, both ionic compounds and polar covalent molecules will also readily dissolve in water. And as we talked about, so ionic compounds will separate, as will polar covalent. And so, again, when we look at water, then there's no one of those characteristics which are completely unique to water. But water is a unique substance because of that combination of characteristics. So there's no one of those that's unique to water, but the combination of characteristics makes water a tremendously unique substance in nature.